Hello, everybody. This is Robert Hodges, and I'll be your presenter today at the Altinity webinar on handling log data in ClickHouse. We're delighted you could attend today and look forward to telling you what we know about this subject. Before we dive into the webinar, I'd like to just give you a couple of bits of information that may help you. First of all, this webinar is being recorded, and so we'll send out links to the recording as well as the slides after the webinar is done. You'll probably get them within about 24 hours. Also, if you're familiar with Zoom webinars, you probably already know this, but there is a Q&A box that you can use to ask questions. If there are things that are relevant to what I'm talking about, I may take them during the conversation. Otherwise, we'll have plenty of time at the end to take questions and address things that are of interest to you. Finally, speaking of the end, we will have a little poll. We do this with every webinar. Our goal is to make the webinars as useful to people as possible. So we ask you 3 questions at the end that help us gauge, was this the right level of technical detail? What's your stage of use of ClickHouse? And finally, what other topics would you like to see? So if you'll stick around to help fill that out, you will do your part to make these webinars better in the future. And one final thing that I should mention, since it's relevant to today's webinar, I have a terrible cold, so you may hear me cough a little bit. I'll try and drop off and prevent it from disturbing your webinar experience. Apologies in advance. All right, let's dive in. So a little bit of introduction both to Altinity as well as myself. So Altinity is the leading provider of software and services for ClickHouse. We basically make ClickHouse safe for enterprises. We are the #2 committer now in the ClickHouse ecosystem and a major community sponsor in both the US and Western Europe. If you attend meetups in any of those areas, we've probably seen our folks present. As far as my own background, I'm CEO of Altinity, but more relevant for today's webinar, I've been working on databases since 1983. ClickHouse is the 20th one I've worked on, although you tend to lose count after a while. But it's, I think, far and away one of the best ones. It's a really wonderful piece of software. And the picture is what I look like when all my samples work. All right, enough of introductions. Let's dive in. Oh, I was accidentally muted. Let me repeat that. I'd like to give a slight marketing introduction to ClickHouse for those of you who may not understand it or have used it before. So the ClickHouse, the way I like to explain it is that it's kind of like a combination of MySQL and Vertica. So imagine MySQL and Vertica got married, they had a baby, that baby would be ClickHouse. So from both the parents, it understands SQL. And the code is not shared, of course, but we've been inspired by many of the ideas. So we understand SQL. Like MySQL, we can run on everything from bare metal to the cloud. So MySQL runs practically everywhere, very easy to manage. MySQL, of course, is open source. ClickHouse is Apache 2.0, which makes it very easy to use and reuse in other applications. From the Vertica side, we have a number of important similarities. So, for example, shared nothing architecture, which gives us the ability to scale out very well. We use column storage. That's very, very important for analytic applications. And basically, it means that the data are stored in arrays. They are highly compressed, and there are ways that then we can read them very efficiently. In particular, ClickHouse has very strong parallelization capabilities, both MPP enabling, which means that we can run queries, distributed queries across many nodes. We also have the ability to do what's called vector-wise query, where we break things up locally on the host and farm it out to all the vCPUs, or CPUs, as the case may be. And of course, like Vertica and many other great analytic products, we scale to many, many petabytes. The large ClickHouse can be used anywhere from a laptop. That's where I've been using it for this, to prepare for this demo, all the way up to clusters that consist of hundreds of nodes and contain 15, 20, 30 petabytes of data. So that's it for ClickHouse. If you want to find more about the details, we offer many webinars on this, and feel free to look at those or check out our blog articles or the ClickHouse documentation itself. Oh, looks like I see some participants raising the hand. Looks like I am muted again. I apologize. This is having some problems with the mute here. Okay, let me repeat that. Why is log management interesting? So logs are one of the biggest sources of data about operational systems. And service-oriented architectures is not enough just to look at one log. You often need to scan many because transactions will occur across multiple systems. Here's a simple example. In the in the picture here, let's say that we have a cloud-native system. It's got an API endpoint that's exposed to applications, and you start seeing HTTP 500 errors in that API endpoint. So these are REST calls that are failing because of a back-end server. So what you'll then do is, in order to diagnose this, you'll need to associate that HTTP 500 error with the fact that in other logs in your back-end services, you might be seeing, for example, a certificate validation error. Once you see that, you can point to the root cause, which is that you have expired X509 certificates on a third-party cloud service. So this is an example where the ability to have this information in a database and associate it rapidly is incredibly important to making to allow systems to be both reliable and also to recover very quickly from errors. So that's why the problem is interesting. You probably already knew that, otherwise you wouldn't have signed up. So what I'd like to look at now is just the general log management architecture. So there are a number of systems that do this, and I think it's fairly well understood how to design them at the macro level. So on the left side, you'll have some set of logs that you're ingesting. For example, you might have microservice logs, so things from Docker containers running in Kubernetes. You might have web logs from internet-facing proxies. You might have database logs, which are, for example, your MySQL slow query log, which is providing information for about the state of MySQL. Excuse me. These are things that we will feed into the ingestion pipeline, and the idea is these will all be stored somewhere suitable in an analytic database that is capable of scanning the data very quickly and making associations between log records. And then finally, there's a couple of useful kinds of output from this sort of system. The first is you want to be able to have alerts. So for example, in that if you do see HTTP 500 errors and you don't expect them, which you normally don't, you would like an alert to be generated so that somebody would be told that this is happening. so that you notice it before your customers start calling you. The second thing you want to be able to do is run analytics. So, for example, have dashboards that visualize the behavior of the system from log data, as well as the ability to do quick interactive queries. Again, once you see an HTTP 500 error, you're going to need to go in, dive, do queries, for example, where you will ask, hey, where do I, if I see an HTTP 500 error, can I make an association between that transaction, between all the log entries for the transaction that was associated with that error? So that's your interactive query part. So these are the general parts of the log architecture, and our plan is to address all of these over a series of webinars. But for today, we're going to focus on a relatively simple part, which is just the analytic database. And we're going to talk about how ClickHouse can actually model log data and give you the tools to set up basic log processing architectures. In future webinars, we'll cover some of the other topics in much more detail. So let's have a look at the data layout for weblogs. And I've picked NGINX as an example because it turns out that if you're running NGINX, there's a way to get the NGINX to generate the data automatically in JSON format. Now, JSON is, as it turns out, is an incredibly helpful format for many types of log data. If you can get it into JSON, it then makes things much easier inside ClickHouse. So for this example, I've taken, and the examples that you see throughout this talk, I've taken some NGINX access logs and turned on the JSON format, and then I'm going to be showing you how to load them into the database and get information out of them. So there you see JSON. It's a bunch of key value pairs, basically. The actual format, when you see it, this stuff, I've run this through JQ so that we can see it easily and you can get a sense of the kind of information. But NGINX will automatically put this on a single line, and that's a standard way to represent this data. You basically have a JSON document on each line of the log. Now, as we look at how to model this in ClickHouse, there are three general ways that we can attack this. So, as you probably know, if you've used SQL data warehouses, SQL likes things to be in tables. So one kind of obvious way to store the logs is actually just to take each of those values and load them into scalar columns in a SQL table. And in terms of using SQL, that's actually the easiest way, and what we'll show you over the course of this webinar is how to get there. But when you're starting out, and for example, you have multiple log types or you're not sure which columns are most important to pull out, it turns out that it's actually very useful to adopt a log form where you have a few header values and you have what we call a JSON blob, where you take that JSON structure that we showed in the previous slide and you just store it as a string inside the table. And then we can extract information from that, but we have to do a little more effort. There's another way to model data in ClickHouse, which is to have the header columns, as we described here, but then have an array of keys, which those would be the names of the JSON fields, and an array of values, which are the values of each of those fields. We're not going to discuss that today. That format can be used for logs, but generally speaking, it's one that people tend to use a little bit more commonly for time series data, which has a lot of variable properties. We may talk about this in later webinars. So let's jump in, and what we're going to do is start and show how to manage logs as JSON blobs. So that was the simplest way to get started. So this is pretty easy to do because all you're going to do is design a table which has a few bits of header information. In this case, I've got a table called log row, and every row from the log is going to have a field that says, hey, what date was the file generated that it came from, what's the file name, and what's the file timestamp. I would probably, if I were doing a real system, I'd probably add the line number as well, but I didn't do it in these examples just to keep them a bit shorter. The last thing is the row. That's just going to be the bit of JSON, and it's simply a string. And I'm using the merge tree table engine here. That's the standard workhorse engine in ClickHouse. I'm going to be partitioning by the file date. That's going to enable me to find these files quickly. Because they'll be split into parts, ClickHouse can then decide which parts it needs to read. And I'm going to order by the file name so that within the parts, we'll basically have everything for a single file name together. One thing I'm going to do here is, it just happens I'm setting the index granularity to 512. I'll talk about that a little bit later, why we might do that in this particular case. So that's the table design. It's bone simple. And we do have to do a little bit of work here to get that nice JSON that NGINX has provided for us to put that into the table. And what I did was wrote a very short Python script. That's kind of my go-to language when I'm doing this kind of thing. And what it does is it basically opens, it will accept these NGINX log files, and it will basically list each line and also add the file name, the date, and the timestamp for the file. So that's just going to be, and it's basically going to put it in CSV format. And this is nice because CSV is very, very easy to load into ClickHouse. So I have this script, really simple piece of code, and now if I want to go ahead and load the log files, I just run the following bash commands. So I have a query, which is I'm just going to insert that output from that program, which is called ingestfile.py. I'm going to read the file, generate this CSV output, and then I'm just going to push it into ClickHouse client. And it's going to go into my log row table that I just defined a few minutes ago. So that's basically how I get information loaded. So once I've done that, it's kind of interesting to just see how big the data is. This was just a couple files with some very trivial generated data that I forced a bunch of calls to the NGINX server using curl. But one of the things you want to look at once you load this is what's the size of the data that you're loading. And because that can be very interesting to understand how much data you're going to have to process for queries. So I use this query up above, which is one of my favorite queries for showing the size of columns, both their compressed and uncompressed size, as well as the percent of compression. So we read from system.columns, and when we run this query, which you can just copy out and run, and it'll just pop out all the stats for all the columns in the current database, we see that, for example, that row data, which we just loaded, actually compressed by over 99%. So the compression can be quite good with JSON if it happens to be fairly, if it happens to have doesn't have much variation. In this case, it was test data. If you were doing real log, you would have quite different compression. So that's something we'll come back to, because as we do other manipulations, we do want to check to see how effective the compression is and how much value we're getting out of it. But one of the things that is significant about JSON is it often compresses extremely well because there's a lot of repeated data in it. So this is something, when you're comparing this to other solutions, you want to look at the amount of compression that ClickHouse gives you. Now, what we have in that table is pretty primitive. It's just a string, and it's got some JSON inside it. So the next thing we have to look at is how do we actually fetch data out to get this information. And ClickHouse has a number of useful functions that do this. I'm using the JSON functions, so there's a whole family of functions that basically extract data out of JSON strings. And for example, if you want to get a JSON value, for example, the status that you get in an HTTP request, this is how I would get it out of that blob out of these blobs that I'm storing. So I say JSON extract, give the name of the column, and give the field within JSON that I want to fetch. Now, that's going to come out as a string, as it happens in this case. If I want to type it correctly, I'll have to do a conversion function, 2int16. Finally, once I've got it in this form, I can go ahead and do all kinds of SQL operations. Just as a simple example, I could use that value to select rows. So I could look for everything in the file where the status is either is greater than or equal to 400, so either a client error or a server error. So at this point, I can now do SQL queries quite easily, but I do have this this function that I have to call. So when you look at this and you sort of use the ClickHouse, look at the pages on ClickHouse documentation, you'll notice that there are a couple of families of functions, and it's sometimes a little bit confusing about what the difference is. So the JSON functions that I just showed the example for actually have a complete JSON parser. This means that they will always be able to fetch data out of any properly formed JSON, but they're slower. There's another family of functions called visitParam, and this was actually uses a custom JSON parsing library that was written by the ClickHouse team, and I think you can describe the algorithm as fast but half-hearted. So it's quite a bit faster than parsing fully, but it has some assumptions about the JSON values that may trip you up in certain cases. So, for example, if your JSON contains any spaces outside of that are not inside of doubly quoted strings, the parsing will fail. But on the other hand, so if your data is properly formatted, these can work, but otherwise you're probably better off using the JSON functions. So at this point, you can actually do quite a bit of querying on the on the JSON data, and in fact, for simple cases, if you just had wanted to do something that you set up in a couple hours and just find out what's going on in your logs, that actually could be all you need. Now, over time, what we want to do is we want to move closer, we want to move away from JSON and having to do these complex function calls to get data values out and get something closer to a tabular schema. So in this next section, I'd like to show you the next step that we take in order to get there. So tabular form is great because it makes queries easy to write. So here's an example. We're selecting the remote address, sort of the source address, the status, and the count, and we basically like to find out who's generating which status codes when they make calls, because perhaps we have somebody that's generating errors and we want to see who they are. The question is, what is it we actually select out of that can give us this answer? So if we wanted to get all of the JSON data, we could actually run a subquery, and this is the values that you see right here. This subquery will select every value out of the JSON, give it a reasonable type, and then you can refer to it by a nice name within your query. But this is pretty painful to do and not something that you would want to have in every query. It's also slow because you're, of course, recomputing these each time. So let's use a really great feature out of ClickHouse, which are called materialized columns. What we're going to do is we're going to take specific values out of that JSON and we're going to incrementally turn them into columns. You can do this through an alter table, and there's two forms that you can do this in. We call the one form, we call them in general materialized columns, but I'm showing two syntaxes here that illustrate how this works. The first is to add a column and set a default value. This is actually the recommended way to do it. It will set the value. Here's the extraction that we do on the status value to get it correctly typed to an int16. And then, in order to, and when you issue this command, it's important to note that nothing actually happens inside the table itself. If you go look at the columns, things will still be computed, but you can force the value to be fixed just by doing an alter table update. And this is very handy because it minimizes the amount of data that has to be changed to get this to force this value to be properly materialized. The other alternative is to use the materialized keyword, which has a very similar effect. As you can see, it's almost identical syntax, other than the materialized keyword. But the difference is that the materialized keyword, when you do this, ClickHouse will continue to compute the data until you either have new data inserted or you do an optimized table. The default actually would be correctly computed on any merge. So, and the reason this is significant is that if you had a bunch of existing data and you wanted the columns to be fully materialized, this is very common, and this is a problem we've dealt with with customers who run large systems. What they don't want to do is actually have to run merges on every single part in a large system, which is what optimized table does. So for this reason, we tend to recommend the default keyword as the best way to do this and minimize the amount of work you have to do to get the data materialized. Once you do that, you can then go ahead and check the size. So this is, and as you're materializing things, once they're actually written, they will appear in this query. And so, for example, I can see that this status value actually compresses by about 96%. It's a little bit less good than the JSON text, and the reason is that I was using test data which had very, very similar queries. So that JSON compress incredibly well. In general, when you pull things out and compress them, you're probably going to, in aggregate, over the set of columns that you're compressing or pulling out and compressing, it's still going to be less in size than the original row that you had. So, so as you're pulling these values out and compressing them, it doesn't use as much storage as you think. And of course, there's no effect on performance because this is a column store, and if you don't reference that status column, there's no I/O on it, and it doesn't affect your query speed. Okay, so at this point, we've shown we put things in as a blob. We showed how to use the materialized columns to begin to incrementally move to a tabular format. There's another trick we can use that if we want to come in and go straight to a full tabular format, we can do that using materialized views. And this is the last technique that we'll present today. So what we're going to talk about here is what amount to ETL pipelines. And one of the things that's kind of cool about ClickHouse is that if you need to do transformations on data, ClickHouse has materialized views, which are like they're basically like pre-insert triggers that allow you to take the data in the form that it hits an initial table and then transform it and write it to some other table. So it's an incredibly powerful feature. We use it constantly for doing things like pre-computing aggregates, downsampling data, doing last point queries, cool things like that. We've touched on that in other webinars. But in this case, what we're going to use is we're going to use the materialized view to allow us to read into a generic table, which then calls the materialized view, and then the data gets converted and put in a nice table that's specifically organized for NGINX logs. So let's go ahead and have a look at that. So what we're going to do is create the base ETL table. So this is a very simple table. It has the same structure as we used before, but there's one difference. We're going to use what's called the null table engine. And this is basically a table engine that has no storage. So you might ask, why is that important? Well, the reason is that you can insert into this table, and then any materialized view that's based on this table will fire automatically. So it's a way of inserting a bunch of rows and then having them flow automatically into your ETL pipeline, which is driven by your materialized views. But you don't actually have to have storage for the raw data itself. So this is a useful trick. So we define this. The next thing we're going to do is define a target table for the NGINX logs. And in this case, what I'm going to do is take all the values, both the header columns as well as all the keys that are in the JSON documents, and I'm going to turn them into correctly typed columns. So we define that table. Moreover, we're going to do a couple things that are different from the original base table we defined at the beginning. One is that we may change the order by, because in this case we now know more about the data we're dealing with, and it probably makes sense to do a more detailed ordering than we did in the original raw data. A second thing that we might look at, and this is kind of significant for logs, is that we may have a look at the index granularity. So the index granularity defines how many rows are represented by each entry in the sparse primary key index that ClickHouse uses to look into parts. This is a very important structure in ClickHouse. And the reason it's interesting here is that it is very common when you're processing logs to have what are called point queries, where you just want to look at a specific row. Because, for example, you want to see the exact error that happened in a particular transaction. So you go fetch that exact row. If the index granularity is very large, this is the default value here, what it means is you'll have your one row plus 8,195 other rows that have to, where row data will need to get read at the same time. So that can be, even though we have column storage and we omit columns that we don't want, still we may have to look at more data in the columns than we want. Reducing the index granularity can make that more efficient. This is something you want to play around with. I'm just showing the default, and I just want to highlight that as something to think about in the design. The final part is to create the materialized view. So it looks complicated, but it's really just all of the conversion functions that I showed in that subquery. They're now put in a nice select. And if you haven't used materialized views before, this create materialized view creates a view which has this name logrow ETL materialized view NGINX to logrow NGINX. And 2 means when you get done with executing this query, put the results in this table called logrow NGINX. And that's the select that runs, and it goes off this logrow ETL table that we defined at the beginning. So now we can go ahead and come back and load our data. So I'm going to rerun that command that I showed previously, except this time I'm going to point to the logrow ETL. So it's exactly the same data going into just a different table. We run that command, all the logs get fed in. And then at that point, the materialized views will fire automatically, and now we can go and trigger the and query normally just using the tabular form, normal column names, and we can get the data out very easily. So this gets us to a state where we have the data for our web logs accessible. What's interesting is that this structure that we've set up will actually work for different query types. So what we want to do now is just show how to extend it, because we can still have this base ingest table, which can have the same form. But now let's say, for example, we want to have different log types come in, and we actually want to have them get properly parsed and transformed, and then we'll put each of them in a table for the specific type of log data that we're processing. It's very easy to extend the materialized views to make this happen. In fact, if we want to do branching, as we're showing in that pipeline, all we have to do is add a where clause to the materialized view. And in this case, I just say, and it could be anything, depends on what your data look like, but in this case, I know that NGINX logs have they look like var log NGINX. So any file name that looks like that, I'm going to apply the materialized view that converts NGINX data to a proper SQL column format. So that's basically the techniques that we wanted to describe today. I'm going to go ahead and just touch on a few wrap-up points, because at the beginning of next year, we're going to do additional webinars that talk about building these kinds of applications. So just in terms of storing logs in ClickHouse, some basic techniques that you can look at is when you're starting out, it's great. A great technique is just to store the data, get your logs, excuse me, get your log data converted to JSON. There's many tools that will do that. Some logs are nice and just do it automatically as a log setting. So then you can put them in a table that just stores JSON strings. You can use the JSON or the visit param functions to read them out. And then once you have that and you understand which conversions you'd like to run, you can then incrementally add materialized columns to turn the JSON parameters into proper table columns. And you can do this, you don't have to do it for all of them, you can just do it for only the ones that are of interest to you. It's up to you. And so it gives you the ability to go from a system that's very, very simple to set up and get some initial results to something that increasingly looks like SQL tables. And then finally, as you get deeper into this, you can look at using the null table engine. Of course, you can still keep it in merge table. That will work as well if you want to store all your log data, raw log data in ClickHouse. That's great. But you can use, as we showed, a base table that shows that it contains the raw data, and then you have materialized data that fire on the raw data and convert it to proper tabular format. So this gives you sort of 4 basic things that you can do to begin processing logs very effectively. So, as I said before, this is the beginning. Log management is a really important topic. As I said earlier, it is the biggest source of data for many of these systems. Large IT systems, particularly as you get into things like Kubernetes and cloud-native design, where you have huge numbers of containers running, all generating logs. So we have a number of future webinars which are on tap, but some specific topics that we'll be looking at include getting tools, showing you tools for log ingest into ClickHouse. Not everybody is kind enough to write things in JSON that can just be converted with a few lines of code. So there's a bunch of great tools out there, and we'll cover those. We'd also like to dig into doing query and visualization of the log content. So these are your BI tools. Another interesting topic is how to generate alerts on log events. So there's features in ClickHouse that we can use actually to notify you automatically when something interesting happens. So we'll explore that. And finally, as you begin to run these things at scale, you have to look at performance tricks specifically around log data. I've hinted at a few, but there are things like use of codecs, sort orders, all kinds of other things that you want to be considering as you're processing large amounts of log data. So with that, we're done for today. I'd like to apologize for the technical problems. That was entirely my own fault, and I thank you for your patience in listening. Please, we've got a question. Please queue up your questions, and while you're thinking of questions, let me launch a quick poll, which, if you would be so kind as to fill this out, it will help us. It will help us do a better job on future webinars. And while we're doing that, let me answer the question that came up. So this is a great one. How many columns can I add? Does it depend on which storage engine I choose? The answer is no. ClickHouse basically has, there's a practical limit on columns because at some point, if you have too many of them, you will run out of inodes, for example. And there's a variety of reasons why this happens, but basically you can add as many as you want. So the examples that, and we see people commonly that have hundreds of columns in these data and in these log management systems. So you're not likely to hit limits unless you're doing something very unusual. Okay, great. Thanks for that question. Great. Any other questions? I'll stay on for a bit longer, and we will. How the number of partitions affect the query? Okay, great. This is actually a really critical question. If you're interested in ClickHouse performance, and you need to be very careful about how many partitions you end up generating, and another question coming up. So the number of partitions, how the number of partitions affect the query. Basically, if you have too many partitions, ClickHouse will be slower on queries, and it's quite a bit slower in some cases. So, for example, if I did a performance webinar a couple months ago, And one of the examples showed that you could have a 3x difference based on the number of partitions. So this is something you want to look at. It's not strictly speaking a log management problem, but it's something you always want to consider in ClickHouse. Two things that we find are useful: make sure you choose partition keys that keep the partitions down to a reasonable number. Second thing is when you're ingesting data, if you have it sorted in such a way that it will just drop into one partition as opposed to spread across a bunch of them, that will ensure that you have better performance as well. ClickHouse will clean it up in the background, but in the meantime, it affects your query performance, and it actually overloads the server as it has to merge this stuff. Is JSON the only way to store logs, or is XML possible, or maybe other formats? You can actually use any format that you want. It's just that with JSON, we have these pretty fast functions that extract data efficiently. So the problem that you get is as you get more complex string functions, or as you get more complex string formats, you may or may not be able to transform the data effectively within ClickHouse. That's why we recommend JSON if you can get to it. And in fact, in the later webinars, we're going to be touching on tools that you can use that will transform your logs and into a nice JSON format that's easy to process. If you go and actually look at what the format of logs out in the wild, they tend to be these kind of gnarly string formats, separated by spaces, sometimes separated by tabs, and so you have to do kind of specialized parsing. Most people are not kind enough to even write them in XML. Let's see. There's a question I want to answer. How's the performance? I'll take this one right away. How's the performance with respect to Elasticsearch? Any benchmarks? Yes. We have not run them ourselves, but there was a talk by Content Square that was recently did a very large conversion from Elasticsearch to ClickHouse, and the performance gains and cost gains were excellent. So they got about a factor of their 99th percentile queries, as I recall. I don't have the numbers in front of me, but their 99th percentile queries ran 10 times as fast as they did in Elasticsearch, and they were able to. The system was like 10 times cheaper to run. They also were able to store 6 times as much data on the same hardware. So, because ClickHouse has very, very good compression. So, one of the reasons we're doing these webinars is just to show people that you can do this, and that in fact, if you're using Elasticsearch now and you're doing logs, ClickHouse is definitely something you want to look at. It is very, very strong on this use case. Let's see. Here's another one: how to perform joins in ClickHouse. So it says how to effectively perform joins in ClickHouse. This is a deeper subject, but and again, not strictly relevant to logs. The examples I've shown didn't use joins, but ClickHouse supports right and left joins. If you need to do more than 2 joins, you'll have to put the right side in a subquery. So with joins right now, what we generally recommend is that you make sure that the join data is not too large, because what happens currently in ClickHouse joins is that the right side of the join will be read in first, put into a hash table, and then you'll join with the other side of the left side of the query, or the left side of the join. So we do have there is work going on to get merge joins in. I don't know what the current planning horizon is, or the current deadline is for that, but at that point, joins will become a lot better and will also work well across distributed nodes. So if you're interested in joins, check out one of our ClickHouse performance queries. How about parsing logs looking for specific strings? Yes, absolutely. You can do that. And so when you're parsing logs looking for specific strings, you can go ahead and just look for them using brute force using the functions that I showed you. And that's actually where one of the reasons why the visit param function family was written was they can do that faster, although they don't necessarily find everything. If you do this a lot, we recommend that you go ahead and do a materialized column. It makes your queries easier to understand. The other thing you can do once you're materialized as a scalar column is that you can put a skip index on. So skip index allows you to detect whether a particular block is, or whether, within a part, which marks, these are chunks of compressed data, basically which chunks of compressed data you have to read, and they can make your queries vastly faster. So it's not just the fact that you're no longer scanning the JSON, which is voluminous and all has to be decompressed. You also have the ability to index it. So so you can choose that, and the nice thing is you can try it out. Just if you can find it in the JSON, great. If the performance is not good, create a materialized column. If the performance is still not good, optimize it using codecs. If the performance is still not good, put a skip index on it. So those are some steps you can go through to get that to run really fast. Yes, so you mentioned the sparse index key, the sparse primary key index that ClickHouse stores in memory. Does this index contain pointers to offsets and column files on disk? Answer is yes. It is the way that ClickHouse understands what are the position of rows in each column array. And a key thing about that index is it must fit in memory. So what it does is it effectively gives you the size of those chunks of compressed data, and that's why I mentioned that it's when you think about the size of the blocks in the index, you want to basically consider a number that is appropriate for the type of queries that you're running. If you have a lot of point queries where you're looking for single rows, sometimes a smaller number is more appropriate. Can we have materialized views from different tables? This is a question. You can fetch data from different tables in a materialized view, but you cannot trigger off different tables. There's only one base table you trigger off. So, but you can effectively join on data in other tables. Can you comment on the ability to do full text searches on logs in ClickHouse? Yeah, this is a really interesting question. So one of the reasons that the first difference that I would point out, I think, which is the most significant one, is that ClickHouse doesn't have inverted indexes. And when you're using Elastic or any of the text search engines, they have an index that if you just want to find something, you've got these very powerful inverted indexes that can just find stuff anywhere. ClickHouse does not have that. So if we're going to do a search, it's going to be a linear search, brute forcing our way down either a column, maybe we've brought it out as a materialized column, maybe we've indexed it so we can skip parts of it, but we're still searching a column. In Elastic, of course, you can collect the specific places you have to go out of the inverted index, and then sort of cut to the chase. ClickHouse does have the ability to do for example, to do wildcard string searches. That does exist. So there's regex, fairly powerful regex searches. I'm not actually qualified to comment on how good it is versus Elasticsearch. We will be bringing, this is something that if you're really interested in this topic, give us a call. We have folks that have on our team that have been using Elasticsearch quite a bit and can comment on this and the specific performance trade-offs. Moreover, we will talk about that in future webinars. Sorry, I was stuttering because I was reading the next question. We use Elasticsearch also because of the full text search feature in logs. Is there an alternative in ClickHouse? Yeah, the alternative is that, as I said, you can use the various types of string search. Remember that the data is there. It's just that we may not, because we don't have it's because your indexing is not going to be super efficient when you're searching JSON, for example. It's in the general case where you're just looking for something, Elasticsearch is likely to be faster in that particular case. So, great. Well, I am so happy that it looks like you guys had some really, are the visualization tools already available? Yes. We strongly recommend Grafana. Actually, Altinity is the maintainer of the Grafana ClickHouse plugin. We've done quite a bit of work with that. Grafana is a great way to visualize data. One thing I will say is it does not have eventing connected to it because of the way that the ClickHouse plugin is implemented. It's an external plugin, but it's very good and produces really great dashboards in particular. Tableau is another one that we support. We're doing some work now with ODBC to improve the Tableau support. You can pull the stuff into Excel. I'm about to, not that you're going to do that very often for logs, but just to make a point, we work with things like Excel and then tools like Superset. So the ones that we support are most, because we get the most customer asks from them, are Grafana and Tableau. But if you are using these and run into problems, feel free to drop us a question on GitHub or call us directly. We'll be happy to answer it. Any plan to add a text search feature, adding Lucene? The answer on Lucene is no. But the answer on inverted indexes is we're thinking about it. And inverted indexes have been an ask for a while. We wouldn't use Lucene because we prefer to implement it in C++, something that runs really fast and is well integrated with the existing storage structures. But yes, especially as we get inverted indexes and then have the ability to build out more complex search algorithms, absolutely. So that's something that's definitely on the roadmap and that we're looking at. I just don't have a date for when it's going to be available. Does Altinity have use cases of downloading raw data from ClickHouse? This, I don't understand this question. That's so downloading raw data from ClickHouse. I'm probably misunderstanding the question. But you can download data from ClickHouse in a wide variety of formats. So, for example, I can take a ClickHouse table and I can just extract it. I can just select it out as Parquet. So that's an example. Or I can select it out as CSV. I can select it out as JSON one row. There's a wide range of options that you have for downloading data and getting it into the format you prefer. And so there's a lot of, I think that's actually one of the strengths of ClickHouse, that it does that quite well. Actually, what a lot of people do, ClickHouse, you may or may not know, has an HTTP format, or an HTTP API that you can use instead of the ClickHouse client. A lot of people just go fetch the data using the HTTP format. That gives you a lot of flexibility in terms of how the data is formatted, and it's a good way to extract a lot of raw data quickly, because you can just write a little script. You can even just pull it out with curl. It works really well. Question, can you give an example of a use case when ClickHouse would employ vectorized execution? Yes, all the time. So it is pretty much, let's go to the query result I have here. This is, just showing this on the slide, this would use vectorized execution. So if we had a large enough table set, ClickHouse is going to take the data in ClickHouse is stored in columns. We didn't really discuss storage structure, but the columns are broken up into these compressed blocks called marks. And what will happen is when your query runs, ClickHouse has a setting called max threads, and that controls the number of hardware threads that it's going to try and use to execute your query. By default, it is the same. It is half the number of available hardware threads. So for example, if that number were 4, it would spawn 4 threads and try to read the base data from LogRow NGINX using 4 threads that are just streaming along and basically computing, as it turns out here, what we call sub-aggregates, which are then joined together at the end. So those will be vectorized. And what you'll see, you can prove this with ClickHouse. Take any large data set, dump it into ClickHouse, run a query, for example, doing aggregates, which parallelize very well on single nodes, run htop, and you will see as that query is running, the vCPUs or CPUs, as the case goes, will light up and basically run to 100%, and for as many as you use in any particular query. ClickHouse is very good at this. Loading Parquet files from HDFS. Great question. I don't know the answer to that. You can definitely read from HDFS. That I believe is possible. I haven't done it myself. I think one of the places that we're actually looking at is better support for not just going to HDFS, but being able to read formats from HDFS. The other area of interest in ClickHouse is S3. So in other words, object storage, so anything that's S3 or S3 compatible. Again, you may have S3 files. You can get out to them. ClickHouse can do that now. But what it can't do is read a Parquet file when it gets there. So being able to connect those, have different access, data access methods, and then be able to pick different formats. That's something that we're still working on. But you will see that improve fairly quickly. We have work on scheduled for next year. In fact, quite a bit of work related to object storage. So that's something that if you just keep an eye on our blog, you will see announcements on that over the course of 2020. Okay, well, this has been actually a really great set of questions. Thank you so much. I apologize once again for the technical problems at the beginning. It was entirely my own fault. I appreciate your patience in listening, and thank you so much for filling out the poll. We take this very seriously. And stay tuned. We will be doing more blog articles on how to ingest logs, doing performance, as I said, doing sort of performance optimization. We'll show comparisons with Elasticsearch. We know that's a very interesting topic for a lot of people. So look forward to that, and you'll see the webinars coming up in early 2020. So for now, I'd like to wish you all happy holidays. Thank you so much for attending, and I look forward to talking to you soon. Thank you very much, and bye-bye.